with key concept 8 that talks about electromagnetic forces. In a very simple way, this talks about magnetic field created or generated when electricity passes through a wire. So if we have a wire and this wire is connected to a source of electricity such as a battery, so this means electric current will pass through this wire. So this will allow the wire to generate magnetic field. This magnetic field has a pattern and has a direction. The pattern and direction can be changed based on the shape of the wire. For example, if the wire is a straight wire, as we can see here, and this means there's electricity. This is the direction of electricity, electric current, which is from positive to negative. Now, to know the direction, we use the thumb right hand rule. As we can see, thumb shows the direction of the current, while other curling fingers are showing direction of the field. So this is the simplest way to know. While the pattern, if it's straight wire, it looks like circles, or we call it concentric circuits, has no poles. So here, going to the question in the focused questions, which pattern can be describing the current into a straight wire is perpendicular to the paper, it carries current into the paper. So what is the magnetic field pattern? Obviously, it looks, since it's into the paper, we know we have O shows out of the page or out of the paper, while X into the page. So since it's into the page, using the right hand rule, so thumb is into the page, this means this is the direction of the field. So the correct option is C. Here, the strength of the magnetic field around a long straight current carrying wire, we need to relate the strength of the field with the distance away from the wire. So here we can notice that while moving away here, while the circles are getting spaced away from each other, this means the strength is getting decreased. So moving away from the center means the strength of the field will be decreased. That's why the strength of the field will be decreased when the distance from the wire increases. In the loudspeaker, the magnetic effect of current is used to how speaker is related to this concept, mainly the real-life applications that is related to a magnetic field created around a current-carrying wire. We have the relay and loudspeaker. As we can see here, this is a magnet. It's E-shaped magnet, and around one of the poles we rotate a wire, and this wire is connected to electricity, a source of electricity. Once current is passing through the wire, magnetic field will be created. So as if we have magnet inside a magnet, so we're gonna have force. The force will be generated due to the effect between two magnetic fields. One of them basically generated by the permanent magnet, while the other one generated by electricity when it passes through a wire. So here in this question, loudspeaker, the magnetic effect of current is used to move the coil, so it will vibrate, so sound is going to be created. talking about the idea of Fleming's left-hand rule, when exactly are we able to use this concept? If we have a magnet, as we can see here, and inside this magnet, the two poles of the magnet, we have a wire connected to electricity. So this is a current carrying wire. Let's consider this is the poles of the magnet, north and south. We know direction is out of north into south, and in between we have wire. This wire has to be first of all perpendicular and connected to a source. So we consider this as a current carrying wire. This is a current carrying wire. Is found between the two poles of the magnet. Of course, we know since electricity is passing through the wire, this will allow magnetic field to be generated as if we have a magnet inside a magnet, so it will move. We're going to have force. That's why we're going to use Fleming's left-hand rule to identify whether force, magnetic field, or current. So mainly we need to know information about two of them to be able to identify the third. So as we can see, force is represented, or force or the motion is represented by the thumb, and here this is the magnetic field, while additionally here we need to use same Fleming left-hand rule in case of charges, not just a wire. For example, if we have this is the magnetic field, X means into the page, so direction is into the page as we can see here, while instead of having this shows the magnetic field, but instead of having current carrying wire, we're going to have a charge. So using the Fleming left-hand rule, we're going to get that this is the direction of the current. So this is the field, while this is the current. We need to know motion. Motion will be up, so we'll be going up, but the motion will be curved. So because it's a charge, will be curving up. In case of negative, we're gonna just flip the direction. Here, based on the same idea, if we need to think of answering this question, X means into the page, so the field is into the page, and the current is directed here to the right. So where exactly the motion will be, it's gonna be curved up, so toward the top of the page. Then